Good evening, Bearcats. This is 2.4 complex numbers. The things that we're going to learn about is to use imaginary unit I to write complex numbers. We're going to learn to add, subtract, multiply complex numbers. We're going to use the complex conjugates to write the quotient of two complex numbers in standard form. And we're going to find complex solutions of quadratic equations. All right, let's first start with a little bit of definition. Defining the complex number. Well, first of all, the form of a complex number is written as A plus B I form. And in this case, A is a real number. Okay, so the A is the real number. And the BI is your complex number, or I'm sorry, is your imaginary number. Okay, so BI is the imaginary part, and together they are a complex number. They are called a complex number. Just think about it, it's kind of a complex situation here. Anyway, let's take a look at a couple of examples of what they might look like. So, for example, you might have 2 plus 3i. That would be an example of a complex number. You may have, let's take a situation where we have -5 plus the square root of a -9. Okay, well, we know you can't have a negative, so you would have -5 plus, and this is or minus probably, but plus, and we would bring out the I would replace the negative because I is equal to the square root of 1. We probably need to write that I is equal to the square root of a -1. And so this is the square root of this is sort of like the square root of a -1 times the square root of 9. This would become the I part, and this would be 3, so 3i. So that would be our answer there. All right, I know you've dealt with these before, so let's move on and start combining them, adding and subtracting complex numbers. All right, let's take a look at a couple of examples. Let's take, and I'm just going to kind of write all my examples in several places right here. Let's take 4 plus 7i, and we want to add to that 1, oops, sorry. We want to add to that 1 plus 6i. So we're going to combine the parts that are real. The real part are the 4 and the 1, so we're going to say 4 plus 1. And then we're going to add to that, since this is adding, the imaginary parts, which would be 7i and a -6i. So 4 plus 1 is 5, plus 7i minus 6i would just be I. And that would be our answer. Let's go ahead and do a couple more of these. All right, let's take a look here. We have 3i minus, and then we have a complex number, -2 plus 3i, minus another complex number, 2 plus 5i. So let's see, let's take all the real parts, and we've got to be really careful about all the negative signs, So if we go ahead and distribute through this negative right here, then we would get 3i, and that's a negative, so plus 2, and minus 3i, and then distribute this negative, -2 minus 5i. At that point, we can start combining like terms. Let's combine the real parts. There's a 2 and a -2. Oh, 2 and a -2 actually are going to cancel each other. And so now we're just left to combine the imaginary parts. 3i and -3i cancel each other, so we're left with -5i. So our answer would just be -5i. All right, we've got one more where we're going to add this time. Let's try 3 plus 2i plus 6 plus 13i. Okay, this is a problem that is going to be in the homework set on the board for you to do. So when you get to this problem, you might recognize it if you did it in the video with me here, and you can just write in video if you recognize which one it is. All right, we're going to add. Let's add our real numbers. It's just the 3, and that's a plus 6. And then the imaginary, we're going to say plus. The imaginary is 2i plus 13i. So with that being the case, then we would have 3 and 6 is 9. And we would have 2i and 13i, which is 15. And that would be a go Bearcat. Let's try that again with subtraction. This should have been 3 plus 2i minus 6 plus 13i. And we also had in the front 3i. Okay, so that's where we really should have started. I'll change pen color so we can look at that. So we're going to distribute like we did before and write it as 3i minus 3 minus 2i. And distribute again, negative 6 minus 13i. And now we're going to combine like terms. We have a negative 3 and a negative 6. So a negative 3 and a negative 6. My goodness, I keep writing the problem down wrong. I think I'm a little tired this evening. So let's go like this, and let's try one more time. I keep writing it down wrong. This is just 3 plus 2i minus 6 plus 13i. I don't know what I was doing. It's getting way off track. All right, so again, we're going to distribute the second negative. So we have 3 plus 2i. It'll be minus 6 minus 13i. Combine the like terms. We have a 3 and a negative 6, which is negative 3. A 2i and a 13 is a negative 11i. And I believe that, my friends, is the right problem and will be in your problem set on the board, so you won't have to do that one. Let's keep going. All right, now we're going to be multiplying complex numbers. Let's start with something pretty easy. We have 4 times, and we have a negative 2 plus 3i. All right, so let's take a look at this. Let's just distribute, and then let's clean up our form. So we would have 4 times negative 2, which would be negative 8. And 4 times, 3i would be a positive 12i. Positive 12i. All right, let's do something a little more difficult. Let's take a look at 2 minus I times 4 plus 3i. All right, we're FOILing. Let's be really careful. So we're going to take the first term and we're going to distribute it to the second term. So 4 times 2 would be 8. And 2 times 3i would be positive 6i. And then we're going to take the second term, which happens to be a negative I here, and distribute. So we'd have a negative I times 4, which is negative 4i, and a negative I times 3i, which would be negative 3i. And then we're going to combine, oh, wait a minute, I times I, so it'd be negative 3i squared. Which brings me to something very important about our imaginary numbers. Make sure you have this written somewhere and understand it. I to the first is equal to, I to the first is equal to I. So anything to the first powers itself. I squared equals negative 1. You have I to the third and I to the fourth. I to the third is a negative I, and I to the fourth is a, negative 1, is a positive 1. Is a positive 1. This little chart is really important. It'll help us in several ways. Anytime we're going to use the squared one a lot. Anytime you have an I squared, imaginary squared, you're going to imagine that it is, or you're going to replace it with a negative 1. So we have this I squared, so I'm going to cross it out and think of that as a negative 1. Well, negative 3 times negative 1 gives me a positive 3. So if I scratch that out, I just make that a positive. We have our answer. Go Bearcats. All right, another example, multiplying, and then we'll move on to denominators and conjugates. All right, so we're going to FOIL these together. So you're going to get 3 times 3, which is 9. You're going to get 3 times negative 2i, which is negative 6i. Then you're going to go back here and go negative I times 3 is, or sorry, positive I times 3 is plus 3I. Positive I times negative 2 is negative 2I. And then last is going to be, oops, I just misspoke there. This positive I gets multiplied by this whole thing. So it's I times negative 2I, which is negative 2I squared. All right, once again, let's combine like term. We have a negative 6 and a positive 3. So we have we first have the 9. And then you're going to have, okay, I think Miss Zorn is tired. Let's cross this off and work a little bit different example. I don't know. I kind of wrote that one down wrong. So let's write it down correctly. Let's try I, or 1, plus I. And then we're going to multiply by 3 minus 2I. All right, now let's see if we can do this. So if we do 1 times 3, we get 3. If we do 1 times negative 2I, we get negative 2I. I times 3 is positive 3I. And I times negative 2I, be careful, is negative 2I squared. Watch that squared. So cleaning things up, we have 3. This is going to become a negative 1. So negative 1 times negative 2 makes a positive 2. Plus 3 would be a 5. And then we have, so that's our A, our BI form. We have a 2I and a positive 3I, so we have plus I. So plus I. And then that is our answer. Go Bearcats. Okay, complex conjugates, they happen. It's the product of two complex numbers and can be a real number. When this happens, this occurs, the pair of complex numbers is in the form of A plus BI and then multiply it by A minus BI, and this is called a complex conjugate. So let me give you a couple examples. If I said x plus 2 and x minus 2, those are conjugates. Same terms, opposite signs. If I said the square root of 3 plus 6 and the square root of 3 minus 6, same, different signs, same function. So that's what that is. So let's take a look at a couple of complex values that we're going to look at. So we have 4 minus 3i, and the conjugate would be 4 plus 3i. That's pretty simple. Now, let's take a look at taking the conjugate out of a denominator. Taking the conjugate out of a denominator. All right, let's see if we can go ahead and clear this denominator, and that way we would be able to write our equation or our complex number in a complex standard form. So the first thing we would do would be take this, and we need to clear the denominator, so we're going to multiply by its conjugate. So 4 plus 2i, and we also did that at the top, 4 plus 2i. All right, let's look at the bottom first. We're going to get 4 times 4, which is 16, and you're going to get a negative 8 and a positive 8, which would cancel. And then here you go. You have a negative 2 times a positive 2, that's a negative 4, and you have I times I, which is I squared. That's going to change that to a negative 1, so your 4 then would become a positive 1. So plus 1. So plus 1. Sorry about that. Now, back at the top, we would have to FOIL. 2 times 4 is 8, and 2 times 2i is positive 4i. And then 3i times 4 is positive 12i. And 3i times positive 2i is a positive 6i squared. But immediately, that 6i squared is going to become a negative 1, so this whole thing becomes a big negative. So let's rewrite that. So we have 8, and then the negative 6, so that's 2. And we have a 4 and a 14, that's 16, so plus 16i all over 16. All right, go Bearcats. Let's look at a couple of examples. Let's finish tidying this problem up. So you could write this as 2 over 16 plus 16 over 16i. This would reduce to 1/8. Plus or minus is in the formula. 16 over 16 is 1, so 1/8 plus or minus I. All right, last couple of problems as examples. All right, 2 more examples and we're done. Let's go ahead and clear our denominator here by multiplying by the conjugate. So we would multiply by 4 minus 5i, and we would do that at the top and the bottom. Well, this makes it really nice because you only have the 2 at the top, so that makes it a little bit easier. We're going to want to get this in standard form. Let's look at the bottom first. So we have 4 times 4 is 16, and then their conjugates, so you know that middle term goes out, but if you don't know that, you'd have negative 4 times 5 is negative 20, and you'd have 5 times positive 4, which is positive 20, and that would end up giving us our denominator. Okay, so 16. So then we have 4 times negative 5i, and we have 4 times positive 5i. Those are going to cancel. And now we have positive 5 times negative 5 is negative 25. I times I is I squared. All right, that would cancel out, be a negative 1, causing the 25 to be positive, and all of a sudden 16 and 25 will be 41. 41. Okay, so now our denominator is 41. Let's see what happens at the top. All right, at the top we're going to distribute. So 2 times 4 is 8, and 2 times 5 is negative 10. Negative 10. If we wanted to split that up, negative 10i. If we wanted to split that up, we could write it, and should write it, as a plus bi form. So the a would be 8 over 41, plus or minus the bi part would be your 10, not plus or minus, just minus, sorry. Yeah. 10 over 41i. 10 over 41i. All right, last problem, and then you will be working on your classwork. Again, this might be a problem that would pop up, so if you recognize it, then you can just write in your video notes. You can write those words, and I'll know that you did that. All right, let's multiply our 2 imaginary solutions together. The first thing we do before we multiply is you need to take an I out to replace the negative 1 with an I squared. So, or an I, sorry. All right, I'm going to rewrite this as the square root of 6i times, I'm going to take the negative out of this, the square root of 2i. Now we are going to FOIL or multiply them together. So when we do that, this is all about multiplying these together. You have negatives, or you have the square root of 6 times the square root of 2, which becomes the square root of 12. And we have I times I, which is I squared. I am so tired. I'm so sorry. I'm a little tired, and I'm making a couple mistakes here. So let's take a look one more time. We have the square root of negative 6 times the square root of negative 2. So if we do those together, we're going to pull out our negative. And we're going to take out that negative and replace it with an I. So here's your I, and you have the square root of 6, and you have times I square roots of 2. All right, I times I is I squared, and that would be the square root of 12. Well, be careful, I squared, so we have the square root of 12 I squared. I squared is really negative 1. So we really have a negative square root of 12, which we're going to simplify. 12 divided by 2 is 6, divided by 2 is 3. We have a pair that comes out, 3 stays home. So negative 2 square roots of 3. And I believe that is time for us to be done. Have a good evening. Night, Bearcats.